Now we're recording. Yay! Yay! Structure leads to function. I'm not going to say it again. All right, so we're going to talk about this the whole semester. You're not going to get away from structure leading to function. You're going to see everything is structure leads to function, and it's all chemistry. For those of you who don't really understand where you are, how many of you are biology majors? And how many of you are chemistry majors? And how many physics? Anybody physics? Computer science? Anything else? Any other ones out there? So we really are in the class of people who study really all of this. Biology is hard, right? Because we have to go all the way from the tiniest atoms up to complex organisms. And understanding all of that makes it really difficult. Okay, if you're a chemist, right, you're here, maybe here, right, maybe you're doing this. If you're a physicist, okay, and those people know that, right, if you ever talk to a physicist, good luck, okay, they're some smart-ass people, man. But they're out there. Sometimes having a conversation with them is like on a different planet. Chemists? Great, no problem. Who are those people up there that study cultures and civilizations? Sociology, anthropology, psychology. What do we call those people? So that answer on there was pseudoscience, and I didn't say it, I want you to know. We call that the soft sciences. Yeah, it's a little easier. This is hard. You guys, you know that you're in the top 1% of people in the world as far as your education. Very, very, very few people get to this level where they're biologists or chemists and can understand this stuff. Go to the grocery store. Count 100 people. How many of those people would understand if you were go back to them and tell them about EM?
One.
You. Okay? So you should be proud of yourself for getting this far. But this is not as far as you want to go. You want to go further, which means you're going to even put yourself further up that line. Okay? It's hard. This is not simple. There's a good segue, huh? So water. Water turns out to be really, really important. Let's open a new page on your thing, and let's have another Moodle upload. Okay? I would like for you to draw for me a molecule of water. Draw the chemical formula for water and tell me one incredibly important thing about water that you know. What should be the number one thing you say about water? And upload that as your Moodle upload number 2. Take a picture, upload it to Moodle. And if you need help, let me know.
What did you say about water?
Just draw it and tell me one incredibly important thing about it. Just write with your fingers, if you need a stylus, scratch them. Label it, right? Don't just send me a picture with balls. Did you already send it?
No.
Okay. So, can you listen while you do that? Can you listen while you do that? So water, you are made up primarily, so just overall, 70% of you is water. You are water. Water is a wonderful thing. Okay? One of the things I think is really interesting, in your lungs are 90% water. That seems counterintuitive to me. Okay, what is it if you're 91% water in your lungs? You've drowned, you're dead. Okay? What about 89% water? you're dead. Okay? So your lungs, your brain is 70% water. All right? Your blood is 83% water. You are a lot of water. What happens when you don't drink enough? What's the disease? Dehydration, heat exhaustion, heat stroke. What's the number one organ in your body affected by lack of water? What goes first?
Brain.
Your brain. Has anybody ever been in that situation where they've been in heat stroke or close? And what happened to you?
An ambulance with oxygen.
An ambulance came along with oxygen. Were you talking? No? Did you pass out?
Almost.
Almost. Who else back there? What happened to you?
I passed out.
You passed out. Were you talking before you passed out?
No. I was running, so
You were running.
I don't remember the time.
Were you talking? Was anybody talking before they passed out or nearly passed out? Because normally what happens is you start speaking gibberish. You're talking, but you're not making any sense. Your brain is like all scrambled up. Number one thing that goes is your brain. Okay, does everybody upload it? Okay, let's finish the upload so I can keep going. Look at this picture here. If we look at a bacterial cell, 70% is water, 30% chemicals. When they break down those chemicals, so this is one of my favorite pictures of all time, because what's the thing you have the most of? After water? Proteins. Proteins play a huge role in your cell biology. What's the thing that's least here? DNA. Okay, so this is the dichotomy between Dr. Malone and Dr. Stein. DNA is Dr. Malone, proteins is Dr. Stein. I like to tell her she's got nothing on us. You go take 360 with her, she'll be like, DNA is everything. I'm like, that's all bullshit. All right? Proteins. Okay, you have a little bit of sugars. You have a lot of RNA. That's a little surprising. You have quite a bit of RNA, some phospholipids, some other ions. So the vast majority of you is water and proteins. Okay, is the upload done? And if it's not, I will shoot you in the brain. No. Yeah, I can do that. So let's talk about why proteins and water. What happens? What's good about water?
Polar.
Polar. What's another word I like to hear? It's a solvent. What do you know about oxygen?
It's a piggy.
It's a pig. Piggy what's? What's it a piggy what's of? Electrons. What does that mean? What's it being a pig mean? All right. You sit at the dinner table and you take everything before your siblings get anything. And I'm the last of 5, remember? 5 kids, and fortunately they put me in the middle of the table. So I did have reach for things, but 3 brothers, man, they freaking ate everything. So being a pig means that oxygen wants to have electrons closer to it. Why is that? It's electronegative. That's the word you want to hear. You want to say that word. You want to be comfortable with electronegative. And that is actually what drives biology. Water drives biology. The electronegative nature of oxygen drives biology. What does that do to the water molecule? We said it's polar. What does polar mean, Mike?
It has a positive and negative.
It has a slightly positive charge where?
Near the oxygen. I mean, the hydrogen.
Near the hydrogens, and a partially negative charge at the oxygen. That feature allows for 99% of the interactions that occur in our bodies. Right? Everything, all of you, all of these chemicals, proteins, RNA, DNA, is floating around in water, and that water is going to interact with those molecules. Some better than others. Which ones does it least want to have anything to do with? The lipids, the phospholipids. And that's actually a beautiful thing because the phospholipids want to stay as far away from water as possible, and that's what generates membranes. And they do it all by themselves. You don't have to do a thing. Lipids get made. Lipids will congeal together. Okay, have you ever made salad dressing? Right? If you mix oil and water together, what happens with the oil if you let it sit for a minute or two? Separates out because it doesn't want anything whatsoever to do with the water. That's what lipids, phospholipids, will do. It's a great thing. And it's all about chemistry. So what allowed us to evolve, right? If we look for life in other planets, what do we look for first? Water. We look for water. Because we don't think that life can occur without water. Does anybody have a problem with that? Muhammad and Mike? And the rest of you haven't ever thought about it, have you? Yes, probably does. Because look at it, it's made 70% water. It's a little egotistical for us, we're water-made beings, to think that that's the only way in the entire universe that life could exist. That's my problem with that statement. There could be another whole huge different thing that we haven't thought of. Who's thinking of that? The physicists. That's why we can't talk to them. We can't talk to them. You can't talk to them. They're talking about shit we don't even think about. It is totally egocentric for humans to think that this is the only way life could be. On another planet, that rock that we think isn't living, who knows? It's not living based on our definition. Is that definition the right one? It's right for me. It's right for the exam. That's about it. Okay? Okay, we already said this. We're made up of hydrogen, carbon. To new, I'm making up new stuff for the physicists to figure out. Hydrogen, carbon, oxygen, nitrogen. Look at how little nitrogen we are. Tiny. Calcium and magnesium, we have very low levels. Sodium and potassium, others. All right? Oxygen is everywhere. But you need to understand the theory of 4 atoms. That's it. If you know the chemistry of hydrogen, oxygen, nitrogen, carbon, I always forget carbon, right? We are all carbon-based life forms. And if you're not, that's fine with me. I'm very accepting. All you have to do is be able to put those 4 molecules together. Okay, we're going now we're really going back, right? This is chemistry, baby chemistry. This is the nucleus. It has protons and neutrons. These are electrons. They are in orbitals. How's that? Good. I'm not a chemistry teacher. Okay? And all I know is that we are the interaction of these atoms. Okay? Carbon has 4 electrons in its outer shell. It has a total of 6 electrons. The first shell has 2. You should know this. The first shell has 2. The next shell has 8. The next shell has 8. The next shell has 16. We never get to 16. Okay? We care about 2, 8, 8. Biologists only care about 2, 8, and 8. After that, let it go. Okay? So carbon has 2 to fill its inner shell. And don't talk to me about S&P shit, okay? I don't care. I don't remember. I had chemistry in 1986.
Wow.
No, even before 81? 82. How many of you were born? Okay, chemistry is a long way in my past. Okay? 4 electrons in its outer shell. All of chemistry based on filling your outer shell. All of life is based on filling your outer shell. Who does not want their outer shell filled? Go to the gutter. Go, don't think science. Think dirty. Think sex. Okay, if I have to explain the jokes, it kind of loses a little bit. Okay, so filling our outer shell, chemistry, is really important. What happens when your outer shell is filled? You're satisfied. Naila. Nairi. I knew it was an N. Nairi said she's satisfied. Sometimes yes, sometimes no. It depends. What happens when your outer shell is just, right, here's a little hydrogen, got one electron. What is that hydrogen doing? What does it want to do? It wants to find somebody to share with. Please be my friend, I love you. Right? It's a love story.
Are you going to show that video?
We'll see. Okay. So hydrogen has 1. Carbon has 6. Nitrogen has 7. Oxygen has 8. What do you notice about these 4 atoms that drive life? How many are in their outer shells? How many's in the outer shell here? 4. How many's in the outer shell here? 5. See, all I have to do is hesitate and you guys... 5. How many's in the outer shell here? Okay, great. So now let's go with, how many do I need to fill an outer shell? 1. Sorry, it only needs 1 more. How many does this need to fill it? 4. 3. 2. 1, 2, 3, 4. This is what allows us to complete life. These guys mixing together, they don't need anybody else. Right? They can do it all by themselves. Now we do have other atoms that come in and occasionally we need them. But virtually, they're useless. No. They're just not necessary. So what we're talking about is making covalent bonds. Covalent bonds share electrons. And I love this picture. This is a picture of a cell, and on the cell surface, what do you see? A bunch of stuff. Courtney, I love that you're here. There's all sorts of shit on this cell. Some of this is on the cell, some of this is in the membrane. Right? You see membrane? It's complicated. All of those, whether they're proteins or glycoproteins, they're interacting with one another. Some of them might be covalent. If they're not interacting covalently, what are they interacting by? What's that? Covalent versus? Non-covalent. Okay? And non-covalent is the next thing that makes you happy. Right? If we're talking about sex and filling your outer shell, that's really a non-covalent thing, yes? They are not going to be attached forever. I'm just saying that would be bad. Yes? Have you ever seen a dog? Where dogs mate? So dogs get what's called a tie. And the tie is they're stuck together. And that usually takes 10 or 15 minutes to resolve itself. And that's because the penis, once it gets in, it actually is enlarged and creates a barb that keeps it in the female's vaginal canal so that there's enough time for fertilization, hopefully, right? It's basically trying to keep the sperm in there as long as it can. Okay? It does not look comfortable, Mike. It would not be good. Okay, I'm thinking, okay, the male's penis has been all the way backwards. Have you ever seen this? It's really quite a, look it up on YouTube. It's an amazing thing.
I had a set of dogs and one took off.
They do. The female is like, I'm done with you. Except she doesn't actually realize he's stuck. So she'll just drag him around. It's really kind of, it's not easy to be a male dog. Okay? So these non-covalent interactions you're going to see are really important for biology. Covalent's important. Covalent's really strong. Covalent's kind of permanent. It's not permanent, okay, but think of it as more permanent than not. Non-covalent, the beauty of that is it's temporary, right? And the non-covalent interactions, ionic bonds, hydrogen bonds, van der Waals, and hydrophobic forces, they're very weak, except because there's so many of them happening at the same time, these guys are probably all interacting non-covalently. It would be hard to break it apart. There's strength in numbers, okay? All right, so we just have to get boring a little bit, but there's words you're going to see, and I need you to understand them. If I say subunits, what is a subunit of a protein? An amino acid. Oh, amino acids. You need to know all the amino acids. Ooh, if there's 20 of them, it'll be okay. Okay, what's that? It's all good. So you need to be able to draw the chemical structure of all the amino acids. We'll talk more about that, but you want to get started early. Okay, it's really easy to start. NCC. You've got the beginning of an amino acid. Yes? Okay. Everybody draw with me. Make yourself a page. Existing recording. Does that fuck up the existing recording?
No.
It does? Does it put a new slide in?
No, it just like,
It just sort of keeps talking?
after you get to that point,
Uh-huh.
yeah, it'll just keep
Okay.
going.
Yeah, I mean, I've never listened. I can't listen to myself. It's really painful.
Do we need to upload that picture?
No. That one's just for you. Okay, that was a little learning, and you now know 2 amino acids. Thank you. Thanks for asking. And really, that's what we want to do with the iPad. We want to have you do things in class so that you learn it better. Ultimately, it would be really great not to have you do any uploads. Why do we do it? Because people won't do it unless you actually force them to do it. It's really a strange thing because you all want to be dentists, doctors, veterinarians, pharmacists, but you don't want to do the work, which is, I mean, I get it. Like, I'd like to be a millionaire without doing any work. It doesn't work very well. I mean, it would be great, but, you know, I play the Powerball if it's like some ridiculous thing, but it's not going to happen. All right, so let's go back to this one. So subunits. The subunits of proteins are amino acids. What are the subunits of DNA? Nucleotides. What are the subunits of carbohydrates? Monosaccharides. Okay? Sugars. They're just sugars. But you can make carbohydrates, like big long chains of carbohydrates. What's the subunit of membranes? Lipids, phospholipids, okay? When we start putting these things together, we get things called macromolecules. A lot of this is based on covalent bonding, in particular, right? So amino acids are linked together to make proteins. Nucleic acids are linked together to make DNA and RNA. Not so much phospholipids, they're not covalently linked. Carbohydrates are linked. Right? Usually through either a 1,4 or a 1,6 linkage. All right? What's that?
We'll get there.
We'll get there. We will get there. So you go from that to macromolecules. These macromolecules make these huge assemblies. And putting this together, what is this they're showing you here? That's a ribosome. What's a ribosome made out of? It has a small subunit and a large subunit, but what's in a ribosome?
Like ribosomal RNA.
There's ribosomal RNA, rRNA, and
protein.
they're called ribonuclear proteins, RNPs. Okay? Putting them together in this particular way is all done through chemistry. The chemistry of this leads to the function. You mess up the structure by messing up the chemistry, you mess up the function. You don't live without functional ribosomes. Okay? I am going to try to do a lecture capture by Saturday, okay? I have to go to Fresno tomorrow. So tomorrow's kind of out, but look for it online to watch it before Tuesday. No, you just have to do it. Have a great weekend. Let's draw an amino acid. What did I just say? I said N, C, C. That is an amino acid. Okay? On the left is always the amino terminus. So if that's an amino, what do you know about amino? How many bonds does nitrogen usually have? 3. So if I put some H's on there, how many would I need to fulfill that? 2. Okay, but we're going to talk about an amino acid. And at neutral pH, the pH that you are, all amino acids have 3 hydrogens, making this have a positive charge. Okay? Let's skip the middle carbon for the moment, because every amino acid has what at its C terminus? A carboxyl. For those of us who don't like chemistry, okay, that's a double bond to an O and an O. And what should that O have on it? Okay, so you'll see in some books they put an H on it. It just pisses me off. At neutral pH, it will never have an H on it. It actually has a negative charge. Okay? Always. Always, always, always. At neutral pH, you have a positive charge on the amino terminus and a negative charge on the carboxyl terminus. Okay, so that leaves us with the middle carbon. That's the hard one, right? Okay, how many bonds should carbon have? 4. So one of these is going to be a hydrogen. Please don't forget that hydrogen. It just irritates me and I take points off. Okay, and then what do we put down here? We put R. R is an R group. The R group is going to change. Okay, how about you learn one amino acid today? What happens if you put an H where that R is? That is glycine. Can you remember that?
Yeah.
There you learned 1. You have 19 to go. All right? Do you want to learn 2?
Yes.
So put a CH3 where the R is. That's alanine. Okay? So if this is an H, maybe I shouldn't put that little doodad. Okay, if it's an H, that's alanine, and the symbol for it is A. If you put a C, oh, fuck a duck. That's what I meant. Sorry. Sorry.
The arrow that points downward, that skips back a few steps. Little arched arrow.
Third on the.
So when you want to go back, it's just undo.
Okay, thank you. I'm like, did I draw this wrong? We're talking about the program. Thank you. Appreciate it. Okay, and if we have a CH3, that's an alanine. You do need to know the one-letter symbols. Okay? At some point down the road, I'm going to ask for you to draw for me fat. I don't want you to draw me with a big belly. I want you to draw for me phenylalanine, alanine, and threonine. That means you need to know which ones those are. Right? So, please start learning that. I'll find an app for that too. There's a good game. It's not an app though. It's a computer game. It's like some really old game. Like Battlestar Galactica, where you have to shoot things that are coming down. And this, it tells you the amino acid, and you have to shoot that amino acid.
There is an app for that.
I know.
Playing.
It's a chemistry thing. I'll find the link for it. And I'll if you remember it, send it to me. So I'll post it on Moodle.
Okay.
You know what? If I can play a game and learn something,
That's awesome.
I love that. It just makes me happy. Okay, so this is something you're going to need to know. Now, let's go back. Oh, now it's going to